I'm back again, and we have a question from WASSCE 2024 Core Mathematics, and according to the Chief Examiner's report, only a few candidates attempted this question. So let's see how it goes. In the diagram, which is ABCD, is a cyclic quadrilateral. So ABCD is a cyclic quadrilateral. Quadrilateral in which all the 4 points touches the circumference of the circle. We have been told that line BC and AD are produced to E. We have been given angle ABC to be 2A, this is why we have it, and then angle CEF to be 5A, this is what we have, and angle DCE is 51 degrees. We are tasked to find the value of A and then angle ADC, that is ADC, this angle right here. So let's start. Whenever you have a cyclic quadrilateral, don't panic. There's a property that tells us that in a cyclic quadrilateral, opposite angles are supplementary. It means that opposite angles add up to 180. So we have angle ABC being opposite to angle ADC. So these are opposite to each other, so they add up to 180, and these two angles are also opposite to each other, they add up to 180. Now another theorem is that the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. So we have an exterior angle on this side, so this is an exterior angle of this cyclic quadrilateral. It is opposite to the interior angle, so this is opposite to this. So if angle ECD is 51 degrees, then angle BAD is also 51 degrees. Then if we have angle ABC to be 2A, then angle CDE is also 2A. That whenever you have a cyclic quadrilateral, the exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Let's consider triangle DCE. It's also having an exterior angle. There's also another theorem that states that the exterior angle of a triangle is equal to the sum of two opposite interior angles. So this exterior angle is equal to the opposite interior angle. How many of them? Two of them. We know that angle ABC is equal to angle CDE. This is exterior angle of a cyclic quadrilateral. So what is angle ABC? That is 2A. So we have 2A being equal to 2A. Considering triangle DCE, we can apply the exterior angle theorem and say that 51 degrees plus 2A is equal to 5A. This is exterior angle theorem. Then by solving for A, we subtract 2A from both sides of the equation. This will give us 51 is equal to 3A. Then we divide both sides by 3. We have A to be 17. So we have been able to find the value of A. Then the last part of the question, we are tasked to find angle ADC. This angle we are tasked to find. However, we know that in a cyclic quadrilateral, opposite angles are supplementary, right? So we can say that angle ADC plus angle ABC should give us 180 degrees. Opposite angles in a cyclic quadrilateral, they add up to what? 180. Now what is angle ADC? We have no idea. That is what you are finding. And what is angle ABC? So angle ABC is 2A, but we have been able to find A. So what is A? A is 17. So 2 multiplying 17 should give us 180. Then let's simplify. 2 times 17, that will give us 34 is equal to 180. Then we subtract 34 from both sides. So angle ADC is equal to 180 minus 34. That will give us 146 degrees. So that is the solution to the question of the day. Be on the lookout for the next question of the day as we prepare ourselves for this year WASSCE 2026.